Alright, we're going to cut that itch. Looking good, just a little bit more. We wired up the AC power again. We want to see how much voltage that half-wave rectifier circuit puts out. Alright, it's 10.75 volts. Well, I've been thinking, probably the simplest thing we could do, we have that half-wave rectifier circuit, charges the capacitor, produces 10 volts as we measured, so we need a voltage divider to get that down to 5 volts max for the PIC processor chip, otherwise we'll burn it up. But the simple circuit does have disadvantages, and one is if you make this capacitor too large, then it's going to filter out our power line variations, which is what we want to measure. And if we make it too small, we'll get ripple in our measurement from the AC voltage coming in. We might end up there. But consider a sample and hold circuit with a capacitor divider instead of a resistor divider. So if we have a 10 volt supply and all the switches are open, we close this switch, we charge say a 1 nanofarad capacitor, we then open that switch, we then close this switch over here, which is connected to a 9 nanofarad capacitor. So whatever charge is on this capacitor needs to now be distributed over a total of 10 nanofarads. So by common sense and kind of a intrinsic analysis, we're going to end up with 1 volt on these capacitors because we had to transfer that charge across 10 times what it used to be on. So then we can open this switch, make our measurement with our processor, and it's down below 5 volts, so we've lowered the voltage even without a resistor divider. And then when we're all done, we'll close this switch, which will bleed off all the charge on that capacitor, and we start all over again with charging it up, distributing the charge, making the measurement, discharging again. So up here, which is off camera now, simple solution with some issues. Down here, a complicated solution, but you know, maybe that's more fun. So we'll try that and maybe go back to the simple one if this one doesn't work. So in real life what we have, instead of a 10 volt battery, we have a AC supply. Instead of this switch, we have a diode, which will act like a switch, but the problem with this is we don't know the phase of our AC supply, so we don't know when the switch is open or closed. We then have that transistor circuit for this switch. And if you remember the transistor circuit, if we replace this 51 ohm resistor, take that out, put our capacitor there, cross that out. Whatever base current we put on this transistor is also going to charge that capacitor, so we'll have to take that into account somehow. And this switch here to discharge it, all we'll have to do, right here, all we have to do is change this pin to an output pin, drive it low, that will discharge the capacitor, then change it back to an analog input pin. So we have the basis of a sampling hole there, so let's see if we can make it as such.